when you think about the word relation, it is just a set of values, just like you did with those coordinate pairs. Input, output, all right? Relation does not have any special restrictions on it. It just means that it's going to have an input and an output. The example that they give you is dropping this egg here. This relation is seconds to height, how high up the egg is. And that's going to have a pattern that you could see. Obviously, the longer time it goes, the less the seconds, the number goes down there because it is falling. But this is just a type of a relation. The other type of relation is what you just did. All right, and what you just did was you graphed on the coordinate plane, or you looked at a coordinate plane. So one type of relation that you can have are just ordered pairs. It is an input and an output. The x is the input, the output is the y. And so graphing relations is very simple. You typically graph them on some type of xy type axis. Now, it won't always be xy in the same units. If I was graphing that dropping egg, I would have to label one of my axis as seconds, and I would have to label one of them as height, okay? So a relation doesn't have to be the same units. It can be different units, time versus feet, okay? But the one that you're used to is going to be like coordinate pairs, which is just unit to unit. So hopefully you all know how to graph, since you actually didn't do it in bell work, and I thought you were. Graphing is very simple. The first one tells you whether you go left and right. The second one tells you whether you go up and down. So this first one, I'm going to go left 2, up 4, and I would graph this here. For 3, -2 right here, -1, 0 on the axis, and 1, 5 would go there. All right. When you graph something like this, if they give you labels like A, B, C, and D, you want to always also put those there as well. And so this is just a type of relation. Type of relation is graphing on the coordinate plane. So if you did not do that for bell work, let's do this for this one. You can graph them all on the same coordinate plane, A and B. Graph them, and we're going to talk about a special type of relation. All right, so it should look something like that. You have 0, 4, -2, 3, -1, 3, -2, 2, 1, -3, and I did that backwards. That was -1, -3. We'll move him over. And then for the other ones, you should have had -2, 1, -1, 0, 0, 1, and then 1, 2, all right? So the next terms that they start talking about are the terms domain and range. Domain and range. You're going to see this terminology as we get into functions this year and as you get into functions next year. Because what you start talking about is domain that is defined like this, where they just give you the x's and they give you the y's. Or they give you domain where they give you a function and you have to realize that some things may not work for that function. So when they say domain, they want all of the input. In this case, it's going to be your x values. So domain is talking about your x values. If I were looking at this, for A, I would say, well, I have a 0, a -2, a -1, a -2, and a 1. When you list your domain, you don't have to list duplicates. And you typically list it least to greatest, all right? Range are the outputs. So range is what you get out of it, and that is your y values. And so for like the first one, 4, 3, 3, 2, and -3. Again, you don't have to list your duplicates, all right? So finding domain and range with something like this is very simple. You're literally listing your x values listing your Y values. When we get into functions, it's a little bit more complicated in that you have to look and see, is there a problem with the function? And so if you look at the next example, find in the domain and range, and they have given you this graph here. Well, if I wanted to find my domain, I would just look at all of my X values. You can see that you use the X value 2, you use the X value 3, X value 4, 5, and 6, all right? So that would be my domain, 2, 3, 4, 5, and 6. For my range, I'm gonna say, well, I have a 4. This looks like 4.5, then 5, 7, and 7.5. So that would be my range. So finding domain and range is very simple. To list it out, you want to actually list it with your set notation. All right. So what they did here is they listed all the points that they had: 2, 4, 3, 4.5, 4, 7.5, 5, 7, and 6, 5. They listed these points, and then they took the 2, 3, 4, 5, and 6 and listed that, and they took their range and listed that. Again, you do not list duplicates. You list it least to greatest. No duplicates and least to greatest is how you're going to list it. So go ahead and find this domain and range. Example or check understanding number 2, domain and range for those. So you should have gotten -3024, the range 2, 1, 4, -3, and then for B, -3, -1, 1, and then range -4, -2, 1, 3. Why did you diagrams? So mapping diagram is just another way to depict a relation, okay? So one way is the coordinate plane, which is what you're very accustomed to. The mapping diagram is another way to do it. And with mapping diagram, you're literally just doing a box for the domain, doing a box for the range, and then mapping them across with an arrow, okay? And this is going to help us when we define function. This will help us to easily see the function as well. And so mapping diagram, you have to have everything here and you have to label it. I'm saying that because this is the most common thing that I miss when I do a quiz, is people just don't label it correctly. So you have to draw your rectangles, and you want to do one rectangle for your domain and one rectangle for your range. And so you're going to literally draw one here, draw another one. I expect them to be as perfect as those, right? And then you're going to say domain and range. And so for these, you're going to look at what they gave you. And for domain, you would say, okay, I have -1, 3, -5, 3. So I'm going to list that -5, -1, 3. Okay? So now you're listing them down least to greatest. Okay? And I'm going to do the same thing with my range. For my range, I have -2, 6, -10, 2. So I'm going to say -10, -2, +2, +6. All right? And once I've done that, I am then going to draw an arrow from the domain to the range that it matches. So and I usually just do it in the order they gave it to me. So -1, 2. So I'm going to go from -1 to 2. All right. And then 3, 6. So I'm going to go from 3 to 6. -5, -10. I'm going to go there. And then 3 to 2. I'm going to go here. And that is my mapping diagram. You have to have a box on the left for your domain, a box on the right for your range. List them and then just draw an arrow. So go ahead and make a mapping diagram for those two right below it. So now we're going to talk about a special type of relation. A special type of relation called a function. A function is a relation in which each element of the domain is paired with exactly one element in the range. So this means that for every input, there is only one output. I like to describe it as though if you're doing a self-checkout, okay? So you go to Walmart and you're ringing up your groceries. Let's say I bought 5 boxes of cookies, right? All the same exact type of cookie. If I run that barcode across that scanner, it should give me the price of the cookies. What one barcode input gives me one output of price, okay? Now, if I have these same exact cookies, the same exact barcode, and I ring it up and it is $2, and I ring up the next box and it is $3, we have a problem, all right? The same barcode should give me the same output every single time, okay? So that is my expectation with a function. If I input, I should get only one output for that, or it does not make sense. Now, it's not reversed. It doesn't mean that I couldn't buy a box of cookies and a loaf of bread and those both be $2, right? That is still a function. Having 2 x's going to the same y is fine, but having 1 x going to 2 different y's is not fine, all right? So you just have to think about it. The input needs to give you only one output. It doesn't mean that multiple inputs could not give you the same output, but it means that one input could only give you one output, always, in order for it to be a function. Some of the ways that you can tell this, you can easily identify it, is through the mapping function that we just did. The mapping diagram easily lets me see if I have a function. Look at the example they've given us. A, I have -2 giving me -1 and +3. This is a problem because my input gave me 2 outputs. So this first one is not a function. That's not a function at all. Look at the second one. -1 goes to 5, 0 goes to 3, 2 goes to 3, 3 goes to -1. I have 2 of my inputs giving me the same output of 3. Perfectly fine. This is a function. This is a function. Meaning I cannot have 2 lines coming off the same number, but I can have 2 lines going to the same number. All right? So every input has to have one and only one output. That defines a function. All right? The other way, and we'll go ahead. Yeah, we'll go ahead and actually talk about the other way before you do them. So look at the other way here. Check understanding 4 is a mapping. You're just saying it's a function or not a function. And check understanding 5 on the next page is graphs. And you're just telling me function or not a function. All right, let's look at these. The first one, function or no? Yes, that's a function. What about this one? No. All right, vertical line test. The other way is the vertical line test. All right? Vertical line test is also a very simple way to see if you have 2 outputs for an input. The reason is, for this first one, if I draw a vertical line anywhere on the graph and I cross it more than once, I have a problem because that means this x value right here is giving me 1, 2, 3 y values. My one input is giving me 3 outputs. This is not a function. So if it is a function, you should be able to draw a vertical line anywhere on the function and cross it at most 1 time. Okay? If you cross it more than 1 time, it is not a function. And we will get to functions where you cross it no times and it's still a function. But if you cross it more than 1 time, it is not a function. It is a relation. It's still a relation. You still have inputs and outputs going on, but you do not have the more specific relation, which is a function. All right? So look at check understanding 4 and check understanding 5. And go ahead and tell me if it is or is not a function for those. What about the first one? No. This is not a function. Why not? Yeah, right anywhere on that you're going to cross it. What about this next one? Yes, that is a function. What about this last one? No. Where's your problem here? Yeah, over here and over here. You can see that if you were to draw a line, you would have a problem there. Function notation. So, function notation, there's a couple ways that you can do it. The first way that you are used to is having y equals mx plus b, right? That's a function that we dealt with last year. That's a linear function, okay? The other way is to write it in this type of function notation. F of x is how it's pronounced when you sound it out in actual words, or a function of x. But it is written with this little script f, parentheses, and an x. And it means f of x or function of x. What it means is that f of x represents the output. You could just as easily put a y there, and it's the same thing. It does not mean multiplication, okay? So it does not mean you are multiplying f times x. That is not what this means. This means that you are finding the value of what happens when you plug in x to the function, all right? And so they've given you this example, f of 3. F of 3 just means you take whatever function they gave you and plug in a 3. Here are the examples. My input here is 5. The function is to subtract 1. My output would be 4. If I were to write this in function notation, I would say f of x equals x minus 1. That's how I would write that first one. And so if I wanted f of 5, all they want me to do is subtract 1. So f of 5 equals 4. The way I'm accustomed to writing that is an ordered pair. Well, my answer is 5, 4, input, output, okay? So when they just have f of a function, they just f of any type of function, x, whatever it is, the variable that they've given you, they are just saying that is the input, f of that is the output. So this is the same as if I wrote it y equals x minus 1, okay? My input was x, my output was y. And we are just replacing that y with the function notation f of x, meaning that I am looking at a function of x, x being my input. All right, look at the next one they gave us. Look at the next one. My variable is a. They want me to add 2. So a plus 2 is my output. This is also my function. So I would write this f of a equals a plus 2. I'm just saying my input is a, my output is what happens when I add 2 to that number. Look at the next one. Input is 3. My function is g of 3, all right? G of whatever, f of whatever is just your output. They are just replacing that with a new notation. It's a new notation, all right? And then they've given you the last one that you're used to here that they talked about at first. My input is x. My function is some function. They'll define it. So f of x is going to be my output. My output is my y value. They're just representing it with f of x. All right? The area of a square tile is a function of the length of the side of the square. Write a function rule for the area of a square. Evaluate the function with the side length of 3.5. All right? So my area. And typically when you're writing these, you will note your function with whatever variable you're talking about. So very often they'll say area as the function, and then side length, that's my variable in this function. So the area is a function of the side length. How do I find the area of a square? What do I do with that side length? Area of a square. The area? Yeah, you square it. So it's side squared, right? Does everybody agree that's the area of a square? Yes. There we go. All right, so now they want me to evaluate it at 3.5. Okay, so they want the area when my side length is 3.5. What am I going to do with that? 3.5 squared, which is what? 12.25? Yes. All right. That's all they want. So the input is my 3.5. The output is my 12.25. Make sense? All right, let's look at the one they want to do. This is how you're going to see it very often. They've given you functions, and they've defined them different ways. They want you to find them evaluated at these 3 numbers. So go ahead and find those evaluated at those 3 numbers.